Students, welcome to online class. On continuation of our previous classes in measurements, third semester, electrical and electronics measuring instruments subject EE 304 C18 scheme. We have seen induction single phase energy meter. We have seen single phase energy meter and three phase energy meters. What are the common errors may be occurred in energy meter? In this session, we are going to concentrate few errors generally occurred in energy meters. Let us see each error step by step. And before that one, the courtesy to all authors who have contributed their knowledge in internet, that is helpful to students. Recap. What we have seen in previous classes: construction and working of single phase induction type energy meter. Okay, so what is just one second, you can see the what is the construction. As we know that the energy meter, what is the energy? So power is equal to, that is equal to V into I into, in case of AC induction means cos phi. This is the power. Energy is equal to, that is equal power into time. So what is the unit? WH or sometimes kWh. Okay, so this is the energy. And how it will measure the energy? By using our energy meter. As we know that this energy meter consists of two main coils. One is the current coil, another is the pressure coil. Okay, so you can observe this is in our domestic appliances, and there is a one disc will rotate. Okay, so it has what will happen? The power energy is equal to, that is equal to P into T, power into time, power in watts, time in seconds, and we can write the V into I into, okay, and you can see the power factor into T. Now the V for PC coil and I for CC coil. Okay, it has two coils. Already we know that what is internal diagram. Let us see once again the diagram. So it has the two magnets. One is series magnet. It is made up of silicon steel material laminated, and upper magnet we can say this is another magnet placed here. This is equal to M1 magnet, this is equal to M2 magnet. Okay, now here I connected the one aluminum disc is connected here, and through one common shaft placed on a jewelry bearings, and it is connected to some resistor mechanism. That means it will count the number of revolutions by resistor counter. Then what is happen? Winding purpose, you can see winding. Now what is happen? Here coming the phase, and the phase wire is connected to, first of all, the few number of turns, this one, and connected to few number of turns and coming here, and where it has the some load connected here. The load is variable and is connected to the neutral. This is the N. Okay, now it is connected to CC coil. We can see the CC coil connected in series with the our load. Now another winding, we can say this can take this winding. Okay, another winding here connected, one winding is no more number of turns with thin wire is connected to the same phase and it's connected to the neutral here. That means this is known as the PC coil connected across the voltage and series coil connected in series with the current load. Okay. Now another thing here can observe, one compensating ring is provided here. You can see shading ring, we can see the shading ring, we can take the another color. So here one shading ring is provided to compensating a ring. Okay, it can easily move up and down movement on a center limb. Okay, these are the physically few parts present in the energy meter. So as we know that, so this is a basic thing. What is the operation? Once it is connected to the supply, we are applying the some voltage, single phase voltage, for example 230 volts 50 Hz. Supply is given to here. So how we are connected here? So this is the phase is connected here and neutral is connected here, and phase is taken out and neutral is taken out. This is the input side, this is the output side. Now once it is the input side, these are the input side, these are the output side. Once input supply is given to this one, what happened? You can see it, the current which is flows, take the another color also. Take this violet color or black color, you can take the black color. Okay, so what is happened? The current which is coming here, it is passing this direction and this direction, you can see it. So once the current is flowing in the PC coil and flowing and coming here, return path, and coming here and coming here, that means circuit is closed. The PC coil, pressure coil, applied voltage of V, applied voltage. So it produces a flux, we can say that is called phi 2. This flux phi 2 is lagged by 90 degrees with corresponding to the voltage. Okay, corresponding to the applied voltage. Okay, the 90 degrees phase displacement between the voltage and flux produced in the shunt magnet is adjusted by the shading ring. Here provide the shading ring. Now coming to the another part. Now it is coming to the current coil. The current is entering here, entering here, entering here, and it is going to the load and path is closed. Then current is passing this loop. What is happened? Here the current flux is produced, this flux. Due to this current, for example, take the CC coil current is directly proportional to the phi 1. Okay, whereas the flux, the V1, that is equal flux, you can say the phi 2 is directly proportional to the voltage. Here phi 1 directly proportional to the current. But here I1 and phi 1 are in phase only. Both are good friends. No phase displacement between current I1 and phi 1. Whereas in this case, the phase displacement between voltage and this is equal to 90 degrees. That means suppose voltage is this direction and flux produced phi 2 is this direction. 90 degrees phase displacement between applied voltage and produced flux in the shunt magnet. Okay, this all are we have seen previous classes. Now what has happened? Due to the flux phi 1, it will flows and cuts links with the stationary aluminum disc. So what has happened? So here aluminum disc, if you are seeing plan aluminum disc, the flux phi 1 comes links with this one. At the same time flux phi 2 also comes downwards links with this one. And this flux is an alternating nature because it's a AC. Then due to the AC, the flux changes. As per Faraday's laws of electromagnetic induction, Faraday's, what will happen? So E is equal to d phi by dt. Okay, then what is the conductor here? This aluminum disc itself conductor. Then once flux changes corresponding to the time, then EMF induced in this one. So due to the E1, there is a E1 voltage induced, eddy current induced in the disc, and due to the phi 2, E2 EMF eddy current induced in the this one. Due to the EMF induced E1, due to the induced EMF E2, so what will happen? This is the conductor, the current is a closed path. Then automatically E2 produces the I2 current and E1 produces the I1 current. What will happen? The I1 current also, I1 and I2 also produces its own magnetic flux. So this own magnetic flux, what will happen? Due to this one, so it is also opposes the cause of its production. Okay, where it is the cause of its production? So due to this one, automatically the flux try to avoid it. Then there is a possible to the phi 1 and phi 2 are stationary parts. Whereas here the flux produced by the eddy currents I1 and I2 fluxes are on the disc. It is placed on a disc. Then it acts as a rotor, it acts as a stator. Due to this one, what will happen? The flux due to the magnetic fields, there is a deflecting torque is produced. Deflecting torque. Due to this deflecting torque, the aluminum disc will try to rotate in the air gap between the shunt magnet and series magnet. So there is a mechanism is provided. So it will slowly rotates. Once it rotated, the spindle also rotates and there is a worm is provided here. It will count the number of revolutions of the disc. Okay, so here what are this is a basic principle. Okay, so how that deflection torque is produced? Due to the flux produced by the shunt magnet, due to the series magnet produces a eddy currents in the disc, and the disc produced currents also produces the own magnetic fields. So these fluxes and main fluxes interaction takes place, thereby a torque is developed due to the disc is placed on the disc act as a rotor and phi 1 phi 2 act as a stator. Then deflecting torque try to rotate the disc in one direction. Okay, so automatically deflecting torque is produced, it rotates. This speed of the rotation depends on the load current. If the load current is more, what will happen? So more flux will come. The more flux, more deflecting torque. Then more deflecting torque automatically runs very quickly, rotates very speedy. So if it rotates, number of revolutions per hour are vacant. So you can take that means, so for example, so it is a 2400 revolutions for 1 hour. You can say for the 1 unit. That means, so number of revolution, this is a meter constant. So sometimes there may be 1500 revolutions for 1 unit. What is the 1 unit? 1 unit is equal to 1 kilowatt hour. Okay, that means 1000 watt hours. Okay, 1000 watt hours. So that means in 1 hour it rotates nearly 2400 revolutions. That is for 1 unit. That means if it is disc is rotating 2400 revolutions, then the digits will change from 0 0 0 to it will goes to the 0 and 0 and 1. And another 2400, then it will goes to the 2 value. Another 2400 revolution, it goes to the 3 1. So these are the mechanism takes place inside the energy meter. Okay, so these are the already we have seen. What are the possible errors may be occurred in our energy meter? Last class I explained one thing. What is happened? Myself and my friend have the same load. Okay, same load, and we operated the same time also, but unfortunately I have 45 units and it has the only 25 units in energy meter. That means what is happened? My energy meter rotation is speed as compared to this energy meter. Then I have to pay the amount. For example, 1 unit is equal to 2 rupees. Then I have to pay how much cost? 2 into 45. I am going to pay the 90 rupees per month. But whereas my friend, he has to pay only 50 rupees. So you can check it. You can see it. Same load. He has the 2 fans. I have the 2 fans, 2 tube lights, and for example take the 1 fridge. This person also same 2 fans, 2 tube lights, same fridge, same, or everything is same. But what is happened? Luckily his energy meter is showing the 25 units, my energy meter is showing the 45 units. Based on this 5 bill collector, you will give the this amount I have to pay. So how it is possible? Due to the error, whether maybe this may be error, it may be this may be error. So I can contact the NPDCL people, the current DISCOM people. So they will check our energy meter on a RSS meter or SS bench. What is the RSS meter? Rotary substandard meter. To calibrate our energy meter. Our energy meter is rotating properly or not. Whether it is running slow or speed. That can be easily identified with the help of the rotary substandard meter. Dear students, these are the tests done previously. Nowadays, there is no disc rotation mechanism. So every energy meter is nowadays we are using the China meters. It's made up of the solid states. That is all are electronic energy meters. But as electrical students, we have to know that. So how the analog energy meter works. Later we will concentrate on electronic energy meter. Okay. So these are the possible mechanism takes place inside a single phase energy meter. Now, what are the possible errors may be occurred in this system? I want to know it. Okay, how can I know this one? So I can easily know that. Now, what are the possible errors may be occurred in the system? Here you can see it. What are the possible? So here, so first thing I can concentrate whether the voltage here. The phi 2, what is the phi 2? And V2, 90 degrees displacement. This is a phi 2 produce shunt magnet field. This is a voltage applied. The angle between these two should be 90 degrees. Sometimes it may not be possible. That at that condition I can make the difference between the voltage and phi 2 90 degrees with help of the shading ring. So this is the shading rings. By adjusting moving the shading ring, I am going to adjust this phase displacement between phi and voltage. At the same time, while disk is moving, okay, so what is what happen? Disk is moving. So disk is placed on a common spindle. Then what will happen? We are going to provide on a bearings. So there is a possible to the friction takes place in the bearings itself. Thereby the rotation of the disk will slow down. Okay, so that can be one of the error may be occurred. At the same time, this spindle also connected to the gear mechanism with a worm, so where it registers the numbers. So due to this friction, the speed of our disk also slows. That is the friction errors. And phase, you can see this is a phase error, phase angle between the voltage and phi 2, the phase errors. Friction errors. And sometimes there is a possible to, if there is no, what is happened here? Suppose there is no load, switch is opened. Here the magnet phi 2 is present, but phi 1 is 0. But it has to, what is the deflecting torque? Deflecting torque is directly proportional to the phi 1 and phi 2. But here phi 1 is the 0. Due to that there is no load, circuit is open, no I1 current is flowing here, so flux is 0. Then deflection torque should be 0. But sometimes you can observe without any load, the small slow rotation of disc also you can observe in energy meters. Very slow movement. So that is known as a creeping effect. What is the effect? Creeping. Slow motion of disc without any load. So what is our aim? So disc has to rotate whenever there is a load on the energy meter. But even absence of the no load, it is also moving slowly, very slowly. So even that slowly, long term, what will happen? It may be revolution takes place, unnecessary recording of the revolution, number of revolutions. So this creeping should be avoided. These are some possible errors may be occurred in our energy meters. Okay, so what is the problem? What is the reason? And how to avoid that one? What are the remedies to nullify these errors? We are going to learn in this session. Okay, dear students. So it is a very easy. If you know the basic parts inside each part work, if you know that, we can easily identify where is the problem maybe takes place. What are the steps we have to take to avoid that errors. Okay, so this is our main aim. Let us see our topic. Now, what are the objective here? On completion of this topic, you would be able to know the following about single phase type energy meter. What are the main be concentrated? So first of all, we can observe the nameplate details. Next, what is the meter constant? Next, what are the common errors? And what are the causes for these common errors? And what are the measures we have to take to avoid the errors? These are the concentration. We are going to concentrate these topics. So if you are observing the nameplate details, so as an electrical student, while we are going to handle any type of the application, we have to check it. First of all, we have to see the nameplate details of anything, any device. If you want to take the iron box, first of all, before going to supply we are going to see that whether it is the voltage, so 230 volts or 110 volts, or it may be 50 Hz or 60 Hz. What is the classification of the class type of the insulation type, whether it's A type or B type or C type. Okay, so as electrical, what is the rate in total full load current? What is the voltage? What is the power factor? All details may be present on a nameplate details. But if you take the motor, so you have to observe, you have to check it. So that may be what is the rated voltage, what is the rated current, what is the rated speed. Everything you have to observe. Dear students, anywhere if you are going to operate any appliances, first of all go and check it the nameplate details, whether it is connected star connection or delta connection, what is the full load torque, what is the starting torque, what is the full load current. Everything you should keep in mind before going to handle that machine. Okay, here small energy meter, the meter itself we are using to calibrate how much the energy we are consuming from discom people. So it should be give the accurate reading. Otherwise, what will happen? There is a disputes between the consumer and owner. That's why our meter should be perfect. Okay, let us see. So what are the things we are going to observe? Here, the speed of the rotation of the aluminum disc of energy meter depends on what factors? So we have seen that load current. If load current is more, what will happen? The current I1 will produce more. At the same time, not only load current, at the same time voltage also. So because load current produces a phi 1 and applied voltage produces a phi 2, and at the same time both A and B. And so here is the discussion point. So we are going to get none of this. So up to we have seen, recalled what we have seen. So here dear students, please tell it, what is that one? the speed of rotation of the aluminum disc of energy meter depends on what factor? Only load current, only voltage, or A and B, or none of the above. What is the answer? Yes, that the answer is the C. Because the deflecting torque is depend upon, so here TD, so deflecting torque is directly proportional to the phi 1 and phi 2. Phi 1 produced by the CC coil and phi 2 produced by the pressure coil. Okay, answer is this one. Okay, very good. Now, what are the nameplate details? So, it will gives the supply voltage, it gives the full load current, at the same time number of revolutions per kilowatt hour, that is the number of units, and meter constant also. And how we are going to calculate the meter constant? We can see here. So, there is a nameplate details present inside. So, inside you check it what is the meter constant. Otherwise, you are going to calculate mathematically as a electrical engineer. The number of revolutions made by the disc for 1 kilowatt energy consumed is equal, we can write it, the meter constant is equal number of revolutions per kilowatt hour. So, previously I told you that, so 2400 revolutions for 1 unit. That means 2400 kWh. 1 unit is called a kW, kilowatt hour. That means 1 kilowatt hour is equal 1 unit. 1 kilowatt hour is equal 1 unit. Okay, so that means its disc rotates 2400 revolutions, that we taken as a 1 unit, or we can say that 1 kilowatt hour energy consumed. So that is known as a meter constant. So number of revolutions for 1 unit, that is called 1 kilowatt hour, is equal meter constant. Is clear? So this meter constant is also changed from meter to meter, company to company. So sometimes it may be meter constant may be 2400. Sometimes it may be 1500 RPM. Okay, sometimes it may be 500 rotations. So there is a one quarrel between myself and my friend. What is happened here? For example, if I take it here, what is happened? So here I have the my house. I placed my energy meter. Okay, so it is taking the readings here. It is rotating. At the same time, my friend also has energy meter. Okay, so it is also taking the readings. This one. So here we have the same load. He has also one fan. He has one bulb. He also one bulb, and he has the another TV. He also TV. Everything is same. Now what is happened? So by using same time, here also same time, shift is the same. Then what is happened? I can observe my energy meter speed of the rotation is very high speed, whereas his fellow the rotation is very slow. That means I can count it for 1 minute. Okay, 1 minute my disc is moving by applying the fan, tube light and TV. At that condition, I can observe number of revolutions takes place in 1 minute. Maybe you can take this 30 revolutions. But while my friend, same fan, same light, same TV, then I can observe his rotation for 1 minute. His rotation is only 15 revolutions. That means my revolution is double. His revolution is 15. That means what is happened? His disc is running very slowly. My disc is running very fast. I thought that my meter is some fault, but actually what is happened? So I complained to the discom people. Sir, so for the same load, my friend is reading the 15 revolutions for 1 minute, my disk is rotating the 30. But he realized that, he told that, sir, so what is happened, your meter constant is equal to, for example, you can take that 2400 revolutions for 1 kilowatt hour, whereas your friend meter constant is equal to 1200 revolutions for 1 kilowatt hour. Even your meter is moving, your rotor is, that is the disk is moving fast, but ultimately after 1 hour he is also reading 1 unit only. After 1 hour it is also reading the 1 unit only. Don't bother about the speed of the meters, but this meter is manufactured by the other company, this also manufactured by the another company. So due to the different companies, its meter constant is different, its meter constant is different. Ultimately we are going to get is same number of units. So for month we are going to the 32 units, so this fellow also going to get the 32 units, then I am safe. But actually lack of my knowledge, I feared. Okay, I feared, that means my disk is moving very fast, so I may get the more rating of the bills. But actually what is happened, that is dependent on the meter constant. Now students, have you got the information, have you got the now knowledge? The disk rotation depends upon the meter constant. So different manufacturers makes different meter constants. So while you have to observe it, what is the meter constant? Meters only. Inside there is it is written on the nameplates. That's why you have to see it, the importance of nameplates. Okay. Now example, you can take the K is equal 750 revolutions per kilowatt hour. That is called, so 1 unit purpose, it has to rotate the 750 times, it has to rotate the disk in between the two M1 and M2 coils. Okay, so here is the discussion point. What is that one? An energy meter has a meter constant of 1000 revolutions. Here is given the 1000 revolutions for 1 kilowatt hour. The energy recorded by it for a rotation of 25 revolutions of disk, so how many units? Very simple. So what is happen here? 1 kilowatt hour, okay, 1 kilowatt hour, it is rotating how many? 1000 revolutions. Okay, revolutions. Now it is asking that, so 1 kilowatt, that means for the 1 kilowatt you take the 1 hour, it takes the 1 hour to 60 minutes, you take the 60 minutes. 60 minutes it is taking the 1000 revolutions. Okay, now so energy recorded by its rotation 25 revolutions, how much? Now you can simply take it. What is happened? 25 units, how many? How much this one? Okay, so we are going to get the simple. So here the 60 minutes, that means 1000 revolutions for 1 kilowatt hour. Now 25 revolutions, how much? It is a very simple, direct. Suppose that means my 1 pen cost is equal to 4 rupees. I require the 20 pens, how much cost? That is a 20 by 1 into 4, I am going to get the 80. This is the cost. Similarly, I am going to calculate that here. What is happen? 1 kilowatt is equal to 1000 revolutions. Okay, now 25 revolutions, how much load? Then what is the value? 25 by 1000 into kilowatt hour. Okay, kilowatt hour. So what is the value here? So you are going to get it, you are going to get 25 ones are 25, 4s are 40, 1 by 40. So 1 by 40 is kilowatt hour. This is the power consumed by this meter. Okay. Or you can say simply 25 by this one. So what we can, so you are going to get is 0.025 kilowatt hour. So this is the number of units. Okay, that is the number of, here you are going to get it. Fraction, this is the only simple. Okay, this is the answer. Or you can say the 0.25 into 10 to the power of 3 watt hour. Same thing, anything you can do the simple. The concept is for 1000 revolutions, 1 unit, 25 revolutions, how many units? The fraction of units only. Okay, that is the simple. Now you can see the what are the common errors takes place inside the energy meter. So there is a possible to occur. The one is a phase error. The phase displacement between the two factors. Here the voltage and flux, and the speed errors, the speed changes, and friction compensation errors. This the friction takes place in the spindle. And creeping error. The creeping error means without any load, the disc will rotate. That is the creeping error. And lastly, error due to the temperature variation, because the meters are exposed to the atmosphere conditions. In winter, in summer, in rainy season, so what will happen? So our meters has the copper winding. The copper is the metal. The metal is subjected to the temperature. If the temperature changes, automatically resistance value changes. If the resistance value changes, the current flowing through this changes. If the current changes, flux also changes. Okay, so because all metals are the positive temperature coefficient materials. Due to this one, what will happen? Automatically the property changes, electrical property changes, and there is a possible to a minor errors may be occurred. That is known as the errors due to the temperatures. Okay, so we will see one by one in details. So this is the physical energy meter, and this is our circuit diagram. Okay, so what is the circuit diagram? What is consist? This is a M2, this is a M1, and this is a disk. And there is a possible to error maybe takes place. You can see here. What are the possible? Maybe error takes place here. Maybe phase displacement take it. So here the shading ring, you can see it. Okay, there is a possible to eddy current. Here also the creeping maybe takes place. So possible takes place this one. The phase errors takes place here. The speed error, disk speed can be takes place here. The friction compensation takes place here. And creeping error, disk, and error due to this one, all windings, this one. Everything is simpler. Okay. Now let us see what is the phase errors. You can see here what is happened. Here is this is the M1 disk current coil. This is the pressure coil. In between there is a disc, aluminum disc. It is placed on spindle and it is connected to the gearing mechanism. Okay. At the same time, the disc also placed in the permanent magnet. So these are the basic things. Let us concentrate this one. What is that one? What are the causes? Phase errors. What is the cause maybe occur due to this phase error may takes place? One is the pressure coil as a small resistance values. So what is the pressure? Where is the pressure coil? Pressure coil is this one. Okay, it has a large number of turns. Very thin wire. So due to this one, what will happen? The resistance value is very less, inductance value increases. So due to this one, the flux of shunt magnet does not lags behind the voltage exactly 90 degrees. That means here for example, take the voltage and it may be the flux phi 2 may be this much, but actually I require for displacement purpose phi 2 should be this one. So I can make from this 2, I can make this one by using the shading ring. I placed the shading ring here. Okay, so this can be adjusted by moving the shading ring up and down. I can adjust the phi 2 and V in between 90 degrees each other. That is a phase error. Okay, so the torque is not 0 at 0 power factor. The power factor at 0, the torque maybe it contains some values. The aluminum disc rotates faster at low power factor. During the low power factor of the load, it will rotate very speed. If the speed rotation of the disc is more, automatically we will get the more bill. Okay, so that's why we have to avoid that type of the situation. Okay, these are the effect. Now how we are going to compensation takes place, then how to avoid this more speed at low power factor? So that can be adjusted by the shading bands. Where is the shading bands? You can see this is the shading band. Okay, shading by adjusting the shading band, we are going to make it forcefully voltage and flux phi to 90 degrees. So then the speed of this aluminum disc at low power factor maintain the constant speed. Okay, the position of shading bands, the position up and down, and one central limb of the shunt magnet. We can provide the shunt magnet as a 3 limbs. So just like what is a shunt magnet? This is this shape now. So we can provide, sometimes we can provide this one. So shading ring is provided here, sometimes maybe here, sometimes maybe here, or sometimes we can use the 3 also. So ultimately we are going to provide the right angles between the voltage and phi 2. The shading band or rings is also known as a power factor compensator. Okay, so why? Otherwise, what will happen? At low power factor, the disc will rotate very. That means, so if I given the less topic, you are ready to do anything. Suppose I given the more homework, then automatically what will happen? Your speed will reduce. Similarly, here is the same thing. But I want the same situation, whether the load is more or load is less, it should rotate constant only. Okay, so that is the main aim of this thing. Now coming to the speed error. So what is the speed error? You can see what is how it will rotate. Here the disc will rotate here, in between the magnets, so voltage coil and current coil. Okay, now what is this one? Errors in speed of the meter when tested on non-inductive load, speed of the meter is either fast or low. Suppose that means if energy meter is connected to the purely on resistive load or capacitive load, then there is a possible to the speed of the rotation changes. If inductive load is connected, the speed may be different for the same value of the watts. So that means the speed of the aluminum disc rotation changes based on the load type, whether it is the inductive load, whether it is a resistive load, whether it is a capacitive loads. So this is a error, I found it. I want to compensate this error. Okay. Now, what is the compensation method? By adjusting the position of brake magnet. So where is the brake magnet? That is a permanent magnet. The speed. So my vehicle is moving very fast. I have to reduce my fuel, accelerator should be reduces, and at the same time I am going to apply my brakes. Similarly, here the speed can change by changing the movement of our brake magnet, permanent magnet inside and outside of the aluminum disc. Okay, so here you can change the position, whether your position is this one or you can insert more, and so what will more current will produce, speed will less. The movement of the poles of the braking magnet towards the center of the disc reduces the braking torque. Then what will happen? More eddy current will develop, more opposition will take place, then speed of the rotor will reduce. Now friction compensation error. A third error is the friction will take place while running our disc. So what are the causes mainly? So unwanted braking torque is produced on the aluminum disc due to the frictional forces at both supporting places. So it may be a disc bearing, it may be a resistor mechanism. So where it will register the number of revolutions, number of rotations. At that conditions also we have some gear mechanism. So that may be create some opposition of the spindle. So that's why the friction compensation we required. What are the remedies? So by making the ratio of shunt magnet flux to series magnet flux largely by adjusting the position of the shading bands. That means here what is that one? Phi 2 by phi 1 should be make as a more. So how it is possible? By changing the shading band, center limb shading band. Okay, then whatever the opposition takes place at the bearings at the resistor mechanism, that can be easily avoided with help of this caretaker. It is a interest here. Shading rings on the shunt magnet encloses the flux in the limb. How that will works? This produces the eddy current itself. What has happened here? So how the shading will takes help will. So because what will happen now? This is the central limb. There is a winding, the pressure coil winding, but I provided the another shading place here. What is happened? Shading ring is the closed one. So this is also linked with the flux produced by this pressure coil links with the shading ring. Okay, shading ring is nothing but what will happen? It is a number of turns. It is a number of turns. Then the current, the flux, this AC flux linked by this number of turns. Then what will happen? As per the Faraday's laws of electromagnetic induction, it is also induce its own EMF. It induces the current is also flowing and it also flux produced. This flux, it is nature such a way that it opposes the main flux. So here also we produce a Vinayaka. This is a Shankara, Shiva. Main flux is the Shiva and this is a Ganesh. There is always quarrel between the Shiva and Vinayaka. So what will happen? Automatically the energy of Shiva reduces somewhat. Okay, so the how much energy we are going to reduce depend upon our Vinayaka power. Okay, so that is the compensation cable. So shading ring on the shunt magnet encloses the flux in the limb. This produces the eddy current in the shading ring. The phase displacement between the enclosed flux and main field in their gap is also produces. A small driving force is exerted on the aluminum disc which compensates the friction. So what will happen? So this shading ring flux also helps to whether it's oppose and support the main flux. That is based on the direction of the flux produced. Okay. So that is the compensation in the friction compensation. So another error is the creeping error. This is a very important and interesting error. What is the creeping error? Slow. It is creeping error is a very slow but continuous rotation of the disc in the absence of the load current is known as the creeping. That means I am not connected any load to my house but my disc is moving very slowly. That is known as the creeping error. So what will happen? If there is no load, it has to stop, but it is rotating slowly. Okay, that is known as a creeping error. So how to compensate that one? So what does the causes mean? Over friction compensation, because here shading ring and we are provided the more number of turns to phi 2 by phi 1 is the more value, and so this all are maybe so enhance the speed of the rotation of our disc. So due to this one, without any phi 1, the disc try to rotate very slowly. If you are observing keenly, then you can know the rotation. There is a red mark on the disc, you can observe that thing. But slow is very slow. So that also we don't want that rotation. So that can be avoided by using a method. What are the method? So what are the main causes is the over friction compensation. Next, stray magnetic fields. So outside magnetic fields may be effect on the disc and disc will try to rotate. Here the phi 1 there is no flux developed because there is no load, there is no phi 1 current, there is no I1 current, there is no phi 1. So whatever the phi 2 unable to rotate the disc, but due to the stray field outside magnetic fields it try to rotate our disc. So this is the one reason. Okay, the over friction compensation and stray magnetic fields. And another is the mechanical vibrations. There is a possible to mechanical vibrations, the disc will rotate. And last one is the voltage supply being excess of the normal value. If the over voltage comes, thereby the phi 2 also produced more and that will try to move the disc. Okay, so these are the 4 reasons of our disc will rotate without our any load. If you are not, our main is switched off, but our meter disc is rotating. What are the reasons? One may be the over friction compensation, another is stray field effects, another is the mechanical vibrations, and another is the voltage supply being excess of the normal voltage. These are the reasons for our disc will rotate. So how to avoid this creeping? This method is not creeping. So how to compensate this one? Let us see. The proper adjustment of the friction compensation. How? So by changing the brake magnet. We have to apply the brakes only. Two holes are drilled diametrically opposite on the circumference of the aluminum disc. This is a one important thing, dear students. It may be asked in any interviews. So how to avoid the creeping? So by, this is the aluminum disc. By providing the small holes on aluminum disc in diametrically opposite side, so we are going to avoid the rotation of the disc when there is no load on the meter. Okay, so if there is no load on the meter, it will rotate. To avoid that rotation, we are going to drill the two drills on a aluminum disc in diametrically. So what will happen? So this is the drill, that means there is no conductor inside this place. So here is a conductor, there is no conductor. So that can be produce an uneven flux. So what is the result? If you are making the two wheels, this causes distortion of the field produced in the disc. Okay, it prevents the rotation when one of the hole comes under the one of the poles of the shunt magnet, because what will happen? So the disc is continuously rotating. Once the hold portion comes exactly nearby the shunt magnet, so what will happen? There is a distortion of field takes place. So this can be avoid the driving torque, the deflected torque magnitude. Then we can avoid this creeping. Okay. So we will see in details next class. So already time is over. Now another, the last is the error due to the temperature variations. So errors due to temperature variations. So how the temperature changes? Based on the atmospheric conditions. Now what are the errors? There are the small as various effects produced tend to neutralize each other, because here what will happen? So errors, whatever the errors occurred in all places, it may be occurred to compensate each other. Sometimes there is a possible to enhance, sometimes it may be stopped. This could overlap each other. So compensate each other. So you can see here, what are the causes? Increase in temperature causes, what is the reason? Increased resistance to the eddy currents path. So reduce the deflecting torque and braking torque. So increase the resistance to the eddy currents and increase the resistance to the shunt coil. Then, so hence the total effect here. So have you understand this one? Okay, I will explain, no problem. So here what is happened? So temperature increases. Okay, then what is the increased resistance to the eddy current? So whatever the disc is present, okay, so disc is aluminum. Aluminum is the conductor. It is also positive temperature coefficient. If positive temperature coefficient, what will happen? If temperature increases, its resistance increases. If resistance increases, whatever the I1 and I2 produced in the disc also reduces. Okay, if it reduces, the flux produced by I1 and flux produced by I2 also reduces. Then what will happen? The opposition for main flux also reduces and it is lower this value. Okay, first case. And second case, what will happen? Our magnets also, what will happen? The upper magnet, okay, shunt field magnet has a winding, and this winding also having winding. What will happen? If the temperature increases, this temperature and this temperature also increases. Okay, then what will happen? If temperature increases, the copper coil also conductor, and it is also dependent on the temperature. If the temperature increases, its resistance also increases, then current value decreases. Here the current value decreased, here the current value also decreases. The flux produced also reduces, here flux produced also reduces. So both are compensate each other. Then finally we are not bothered about this thing, temperature rise. Now have you understood? Okay, so that means whatever the fluxes developed in the disc, that is depend upon the temperature. Same effect may be takes place in the shunt field coil and series field coil. So thereby flux reduction or increase on both sides are equal each other. This compensate each other. No effect on our energy meter. That is the one thing you have to remember. Okay. So these are the errors takes place in our class. Okay. Phase errors. So what are the errors we have taken? So here these are the errors. What are the errors we have seen? What is the phase errors? What is the reason of the phase errors? How to compensate the errors we have seen? And what is the speed error? And how we are going to compensate it? What is the friction compensation error? What are the methods to remedy it? And what is the creeping error? What is the reason for creeping? And how we are going to compensate this creeping error? And lastly, we have seen that the error due to the temperature variation and how this temperature affect on flux produced in the aluminum disc and flux produced in the CC coil and PC coil of the energy meter, and how there is a neutralize each other we have seen. Okay, so these are the common errors takes place in single phase energy meter. Similarly, three phase energy meter also. Instead of single disc, there is a two discs. Already we have seen in previous classes. Okay, so these are the errors may be occurred in energy meter, and that can be easily identified with the help of the rotary substandard meter, which is used in bench at the discom people, the MRT. They will check it. It calibrate the energy meter. Okay, so I think you understood what are the possible errors may be occurred, how you are going to compensate it. Okay, thank you students, and go through the textbooks also. Thank you.